Hi, this is a quick introduction to how to use WebMO and Gaussian 09 in order to do quick calculations for Chem 23S. To do this problem set, you're going to need to find webmo.chem.hmc.edu, and when you get to the prompt screen, the username is Chem23S and the password is structure. Everybody's in the same inbox here, so in order to start your job, just create a new job. It may take a couple seconds for JavaScript to load behind your browser. And when it finally loads, we're just going to click on the periodic table and we're going to build our molecule. I'm going to do NO2Cl. I'm going to do that by starting with the central atom, nitrogen. I'm just going to click any place on here. Add nitrogen. I'm going to go back over here and add the oxygens next. And to do that, I'm simply going to click and drag to where I want them to be on the paper relative to the nitrogen. You can put them about any place you want. I'm going to go ahead and add the chlorine now. If you add them about where your Lewis structure would predict that they would be, you'll find that the calculation runs a lot faster. So there's my quick sketch of NO2Cl. I'm going to go up here to cleanup and choose geometry and let it have a quick shot at that. And now I'm ready to submit my job in order to have its structure optimized. I'm going to click on the forward arrow. I'm going to allow JavaScript to run. And up here in the job, I'm going to put my initials up here so I can find this later. What you find is it will just take and alphabetize all the atoms in your molecule, and that's the way that it names the job. I want to do a geometry optimization. I want to use Hartree-Fock theory. My basis set is going to be basic 3-21G. The overall charge on my molecule is 0, it's neutral. And multiplicity is singlet, and that's just a technical term that we'll learn later on in the course. Means that there are no unpaired electrons in this molecule. With all that done, click on the forward arrow. Yeah, we'll let Java run again. And there's my job right there at the top of the queue. It should take about 7 or 8 seconds of CPU time in order for this to work. Browser will probably refresh about every 5 seconds. There we go. To see my job, I just click on its name. There's my molecule. Now I can twist this around and rotate it and sort of examine it from every different angle. The problem set here asks for the bond length. And in order to do that, what we're going to do is click on the arrow. And if I click on, let's say, nitrogen and then shift-click on chlorine, you'll see that the bond length there is 1.854 angstroms. Now I did not measure the nitrogen-oxygen bond length because that's something that you need to do in your problem set. When you're all done, simply click the forward arrow and you can actually leave your job in the inbox so that you can come back here and refer to it in the future if you need it. When you get all done, please log out. Just a couple of pieces of advice. Please only one molecule at a time in the queue and only draw one molecule on the little electronic marker board at a time. If you put more than one in there, you'll jam the entire system up. Hope this has been helpful. Good luck, and if you have any questions, come see me at office hours.